In this section, we're going to look at different ways of expressing concentration. Several of these we already know, like mass percentage, we already know how to do. Mass of your part over mass of your whole solution. Parts per million, don't worry about. We don't really use that one anymore. Mole fraction, we know how to do. We take moles of part over total moles. Molarity, we really know how to do. Moles of solute over liters of solution. And then the next one is a new one, molality. Molality is really only used in this chapter. It is used for colligative properties. Molality is expressed using a lowercase m. When it's typed, it's usually italicized. And molality is the moles of your solute divided by the kilograms of your solvent. The reason why we use molality in colligative properties is because in colligative properties we deal a lot with changes in temperature. Molarity will change when temperature changes. It's because when you change the temperature, the volume changes as well. You heat it up, it gets a little bit, takes up a little bit more space. You cool it down, the volume decreases a little bit. And so the molarity will actually change a little bit when temperature changes for a solution. But with molality, the moles of your solute don't change if you change temperature. Kilograms of solvent don't change if you change temperature. So molality is useful when dealing with temperature changes because molality will not vary with temperature, but molarity does, so we can't use that. Like I said before, molality is very useful whenever you're dealing with colligative properties. Colligative properties are what we're going to look at in the next section. And what colligative properties are is they are things about solutions that change whenever you put a solute into them. And that's things like freezing point and melting point and some others that we'll talk about here in a little bit. Alright, so let's look at some examples of some of these things. The first example says a solution is made by dissolving 13.5 grams of glucose into 0.1 kilograms of water. What's the mass percentage of solute in the solution? Alright, so we're trying to find mass percentage of the solute. The solute is the one we're dissolving. The one we're dissolving is glucose. So we're going to take the mass of glucose, mass of our part, 13.5 grams, divide it by the mass of our solution, which is going to be our total mass, 13.5 grams of glucose plus the 0.1 kilograms of water, which is the same as 100 grams of water. So this is going to be 113.5 grams. This is a percentage, so we're going to multiply it by 100. And when we get done with this, we get a percentage of about 11.9%. To find the next part, what is the molarity of the above solution? We know molarity is moles per liter. So we're going to take moles of our solute, which again is glucose. So we change that 13.5 grams to moles by using our molar mass. Molar mass of glucose is about 180 grams per mole. And so we're going to get about 0.075 moles of glucose here. We're going to take that moles, we're going to divide it by liters. The density of water is 1 gram per milliliter. So that means that 0.1 kilograms is the same as 0.1 liters of water. When we do this, we get 0.75 molarity, 0.75 molar solution. For the next part, we're answering what is the molality of the above solution. So to find the molality of the above solution, we're going to take moles of our solute, which is moles of glucose, still 0.075, over kilograms of solvent, 0.1 kilograms, and this is going to end up with 0.75 molal. The unit for molality is molal. It's a weird unit. Now the reason why, if we look back at this, the reason why these two numbers are the same, molarity and molality, is because we were dealing with water. In water, the density of water is 1 gram per milliliter, or 1 kilogram per liter. So if you have 0.1 kilograms of water, it's the same as having 0.1 liters of water. But if you have a solution where the density is not 1, then these two numbers will not be the same, which is what our last example is showing us here. Solution has 5 grams of toluene, 225 grams of benzene. It gives us a density. It wants us to find the molarity, and I think we'll go ahead and find the molality as well. In this problem, we have two liquids, and neither one of them are water. So first we have to figure out which one's a solute and which one's a solvent. The easiest thing to do is the one you have the least amount of, which is toluene in this problem. It's probably your solute. The one you have the most of is probably your solvent. So to find our molarity, we're going to take moles of solute. That means moles of toluene. So we're going to turn grams into moles for toluene here. Molar mass of toluene is 92 grams per mole. This is going to be 0.0543 moles of toluene. We need to divide this by liters of our solution. Alright, now to find liters of solution, we need to look at both grams of toluene and grams of benzene and add them together. So it's 5 grams plus 225 grams, so it's 230 grams. We know density of our solution, and we know density equals mass over volume. So we can go through and we can solve for volume and find that our volume is equal to about 262 milliliters. Once we have the volume, we can go ahead and solve for moles per liter, solve for molarity. Go ahead and change that milliliters to liters. And we, excuse me, and we end up with 0.207 molar solution. Now, if we were going to go ahead and do the same thing for molality, which I think we'll go ahead and do, again, we're going to take moles of our solute, so that doesn't change anything, divided by kilograms of solvent. Now, our solvent was benzene, alright, and there was only 225 grams of benzene. And so we're going to do 0.225 here, and we get 0.242 mole. Now again, these two are not the same this time, the molarity and the molality, and that is because the density of the solution is not 1 gram per milliliter.